Okay, we have two more shapes. We're going to start off with definition of a trapezoid. One of the things I want you to know about both of these shapes today, these are not parallelograms. So whenever you're thinking of the properties for parallelograms, they do not necessarily apply to these two shapes. Okay, so we'll start with a trapezoid. Trapezoid, it's a quadrilateral with exactly one pair of parallel sides that are called the bases. So that means it can't be a parallelogram because it only has one pair, then the other sides are not parallel. So does that make sense? The non-parallel sides are called the bases. Or sorry, the non-parallel sides are called the legs. So here we have the two legs, and then on the other sides, we have the bases. The bases are the parallel ones. So we have two pairs of base angles. You want to look at like the two at the bottom, C and D go together. Those are base angles. And A and B, those are the other pair of base angles. Now all four angles still have to add up to what? 360 because it's quadrilateral. But what else could we say? We can also say, what does the measure of angle A and the measure of angle D have to add up to? 180, because these two are consecutive interior angles. So want to keep that in mind. We still have the rules for parallel lines. What other two angles have to add up to 180? D and C. Can we assume?
So not D and C.
Okay, hold on. Okay. Do A and B have to add up to 180? And in fact, just look at them. They're both obtuse angles. Can we have two obtuse angles adding up to 180?
No.
No. And these two are acute.
That's a never.
So we can only say these two are supplementary and these two are supplementary. But is there any relationship between the other angles? No, not necessarily. Not until we get to the next definition. And that is an isosceles trapezoid. So this is a trapezoid with two congruent legs.
Wait, so could you like do a little?
Wait, why is it only say congruent? What about two?
Well, there's only two legs anyway.
Wait, so can you do like a transitive moment for like measure of angle A? Like you replace like the measure of angle A with measure of angle B, and then B, like A and C would equal.
Okay, so listen, Evan, are you?
Well, so, is, so someone texted on the gospel tracker, so we have 220, so I ran class, then I went to gym, but I also said, but now we're here for I just want to show you that I won't.
All right, moving on.
Those two are the exact same thing.
What's wrong?
The first two, they're just flipped around.
Oh, you're okay. Sorry, yeah. So isosceles trapezoid theorems. So if you have an isosceles trapezoid, that implies each pair of base angles are congruent. So again, the bases are the ones that are parallel. So that means the two at the bottom.
And the two at the top.
Right, but it has to be specifically isosceles. So that means if you know one of the angles, you can figure out all the other angles in here.
Wait, those are right.
No, they're congruent angles. Again,
That looks like a square.
Where?
Why the bottom left?
Kind of.
I'm so confused by it.
okay, it's not a right angle.
Because that's a theorem.
Okay.
But why is
In fact,
that's a theorem.
could it be an isosceles trapezoid with a right angle?
No. Yes. Oh.
Okay, but
Sometimes.
It would just be ever.
Yeah.
Sometimes if I don't.
Always.
if I make this, could that make sense? No, that doesn't make sense.
No, I was just
That's
confused.
never. It's a never.
It looks like a square.
But I can have a trapezoid with two right
Not even
angles.
a trapezoid.
It is, as long as you have one pair of parallel sides. So I could have a trapezoid that looks like this. I cannot have one that looks
Wait.
like that.
How do you come
What
up with
if
this
it is-
trapezoid
is a
versus
square
curves? Like,
trapezoid
they're
then?
extremely random.
What did I write at the very beginning of the lesson?
Oh, that's true. That's true.
Right? So this one is just the converse. Okay? So if I know the base angles are congruent, then I get an isosceles trapezoid. So we have,
Okay, what's the difference between an isosceles trapezoid and like a right?
The
legs are congruent to a normal trapezoid.
a regular
trapezoid
a regular trapezoid, the sides aren't necessarily the same.
Okay.
But isosceles, now they are.
Wait, but why are they?
Are there gonna be regular trapezoids?
Like on both sides, why are they congruent?
Okay,
Because they're isosceles.
can I just show you, where do we get an isosceles trapezoid? We get that from an isosceles triangle and chopping off the top. Right? Imagine that these two are congruent, then the base angles are
Side by
congruent.
top.
Oh,
Now, what if I just chopped off the top? What if
that might be the most
these,
genius thing I've ever seen.
right? That's what
That's
makes
incredible.
Oh,
I
it's
just
just
saw
not
some
like-
trapezoid.
I didn't draw that.
Okay.
Wait, if the base angles are congruent, that means that
That makes the sides congruent. Okay, last thing. If we have an isosceles trapezoid, the diagonals are congruent. Okay?
that means they intersect at the angle.
So they don't bisect each other. Okay? If they bisected each other, that would make it a parallelogram. But these two segments are going to be congruent to each other. Okay? Okay, let's draw an isosceles trapezoid.
Diagonals are.
We want to specifically make E, F, and G, H the bases, so I'll go E, F,
Okay, are
G.
they all congruent to each other or just two like?
Okay, if it's a trapezoid, two sides have to be parallel.
How do you draw that
I
so
meant the diagonal.
Only if it's isosceles or the diagonals.
So each part of the diagonals is congruent to each other?
So what parts of the diagonals are congruent?
Are all
Just-
parts congruent?
What parts of the what?
Here.
Every single part of that diagonal.
Yeah, like.
AC then or is it CB?
AC is
Yeah,
congruent.
but what's AC?
Now, also, these two
Are those
little,
all? Yeah.
these two little segments at the top would also be congruent, and these two at the bottom would also be congruent.
What?
So then one congruent, one
Those
and
two
all
parts,
of them.
yeah, that make up the whole thing. Okay, now we have an isosceles trapezoid, and measure of angle E is 7x, and G is 16x minus 4.
Make them equal to each other.
So, in a parallelogram, opposite angles are congruent, but is a trapezoid a parallelogram?
No.
So they can't be equal to each other.
Diagonal.
But
they
what,
can add up to 180.
they can add up to 180. So how do I know that?
I might be.
I know that because the base angles are congruent. So
Oh, so
if the top is 7x, this has to be 7x. And then I can just make the two pair add up to 180. Okay, take a minute. Get 23x. Okay.
what's 17 plus, I mean 16 plus 23.
Well, I wanna do my own.
What do we get for x?
Like,
Light? 8.
I'm gonna guess 8.
So 8.
Okay, so I want to find the measure of each base angle. So E and F are easy. 56. And measure of angle H and G are going to be the same.
Wait, where did we see?
7 plus 8 times
128 minus 4 is 124. Plug it,
Yeah.
plug, right? 124. Okay. One more thing about the trapezoid, and then we'll move on to the last shape of chapter 6. Okay. Median of a trapezoid. This is the segment that joins the midpoints of the legs. Okay. So what ends up happening, so imagine here, this was right in the middle of the triangle, right? We think of, remember when we have median of a triangle, we had from the vertex to the midpoint. This just connects two midpoints. Now, this is not necessarily isosceles. This will be true for all of them. What do you think will happen with the median? It will be, oops. Okay, well, besides that, it's going to bisect because that's kind of the definition. It's going to be parallel. And then we have the theorem has two parts to it. One is that the median is parallel to the bases, and it's 1/2 the sum of the measures. All right. Okay, so I put in parentheses the average. How do you find the average of two things? Add them, divide by 2, right? That's if you have two things. So here, you can either write 1/2 times AB plus DC, or most students prefer to do AB plus DC divided by 2. Same thing though, right? Multiplying by the half is the same thing as
Oh,
dividing
I
by
like
2.
that.
So it doesn't matter to me.
Wait, so how would you?
So EF, the length of EF is going to be AB and DC added
That's how
and
you
divided by
find
2.
the median?
That's how you find the length of it, yeah.
So that's the median of a trapezoid.
Yeah. Okay.
Are we, that's like, you're gonna be on
No, you don't have to do, there's no proof of it. Okay. We know AB is 10, DC is 18. So what is EF? 14, right? We add them.
There's no way. There's no way. I used it.
Easy mental math.
28 divided by 2.
Okay, when you have, listen, when you have really small numbers to work with, just look at it. 10, what's right in the middle of 10 and 18?
Oh, I found 40.
14, right? So you really don't even need to show much work for that. And then for the second one here, if AB is 15, this time I know DEF, and I got to figure out DC.
Wait, can we all, so I can figure this out?
17 and a half.
Oh, that one?
Wait.
Oh yeah, we didn't get to that one yet.
What is going on?
Okay, 20 is the average. Okay, I'm going to show it this way just in case you have like decimals or fractions or weird numbers, right? I would have 15 plus x, and then subtract, I get 25. So DC is 25. Also, just look at it. 15, if you add 5 to that, you get 20. Add another 5 to get 25, right? 20 is right in the middle of 15 and 25.
Wait, 40 minus 15 is 20?
Lily?
I'm not trying to laugh.
Literally exactly like my sister. She laughs at everything.
Okay.
How do you feel?
Well, that was funny.
Okay.
Oh, it looks like a kite. That's why it's.
All right, these two have to be congruent. Oh, you know what? We're also going to do a median in here. I didn't realize that.
I love you.
So Y and Z. Since it's isosceles and the median connects the midpoints, does it make sense that all 4 of those segments are congruent? Okay, that's why I laid it on that way. Okay, what do we know?
Yeah, X is 4.
EF is 3x plus 8. GH is, Okay, how are we gonna set this up to solve for
Add
x?
them and divide them by.
Okay, but which one are we adding, Max?
13 equals 3.
13? Oh, yeah.
Don't forget, divide by 2.
Wait, I won't try to do it. Please look at the board.
And I will freeze the screen.
My brain hurts.
You know what? I'll never divide by.
You can do it.
X equals 4.
No! I always said that.
What?
That's so mean. Literally, it's more broken.
Lily, you did 3x. If you add it, you subtract.
I got x equals 4.
Yes, or.
Yes, 4. Yay. Yay.
Okay, good. X equals 4. Ariel, you good?
Yes, X equals 4.
Kites.
All right, last figure. A kite is a quadrilateral with exactly 2 pair of consecutive congruent sides. Okay, so
It's 4 triangles.
it does make 4 triangles. If you think of, a traditional kite, that is an actual geometric figure. Okay.
We say that when I see someone like flying at me at the park.
What is it like all like 90-degree triangles? Right.
So one of our theorems is with a kite is that the diagonals are perpendicular. Okay? So just like a rhombus, just like a square, kite also has perpendicular diagonals. That's where it stops. Okay? There's no parallelogram here. There's no parallel sides. It also has exactly one pair of opposite angles are congruent. So
How do we know?
it's the one where the 2 non-congruent sides meet.
What?
So not that.
Yeah, it's
Yeah, when I see someone
it's the
flying,
ones
like, Did you know that the person
where the non-congruent sides meet.
is like a 90-degree?
What about Benjamin?
Wait.
What about the
Like
other
a
one?
90-degree.
Yeah.
He's a kite.
Wow.
Yeah, it's really interesting.
Wait.
I didn't.
I left it.
The way you said that.
Wait. No.
Question. It helps to raise a hand.
No. But I
You said the 2 angles on the side out of the 90.
Why is no one here today, but it's like so loud?
Are we gonna get the practice test?
But never changes.
Oh, I get it.
We're gonna have the practice test.
To be fair, I've been doing very well in this class.
I have it.
But I think Liam likes sitting up front too.
Yeah.
Okay.
He's
never here.
One-on-one.
Okay. Which 2 angles are congruent here?
Oh,
W and Y.
On.
Not W and Y.
It's X and Z.
X, thank you, and Z.
Now I'm confused.
Wait, me too.
It's one pair. It doesn't have to be that pair.
Okay, where do the 2 non-congruent sides meet?
Oh, where the
But that one,
Oh.
it would be W and Y.
Wait.
No, Y is small.
Oh.
Do you see these are the
Oh, I get it.
Okay.
I
Now
don't get it.
I don't get it.
I don't get
Because
it.
those are the same congruent. Those are congruent to each other, and those are congruent to each
It
other.
adds up to
These-
3.
Oh.
That was
Wow, that makes so much sense. How do you know which sides are the non-congruent sides?
well, this one has
Equals
1 mark, this
360,
has
right?
2.
Well, no, but let's, okay, but in a proof.
These are congruent,
Or-
these are congruent.
Wait, why do you add 73?
So I want all 4
360.
angles have to add up to it.
360.
I said that first.
360.
I said it first.
I said it before you.
Okay,
I said it in my mind before all of you.
so all 4 angles, right, in a quadrilateral always have to add up. So if we have 3 of them, we can always figure out
Wait, 141, 2,
Plus
342,
315.
315.
Yeah.
360 minus 315 is when we. Oh my god. Really?
X is 45.
What's 360 minus 315?
45.
What?
Yay.
What?
40. See? It's like.
Okay, last one.
No.
So that's an
Oh, that milk was hilarious.
What's the cutest most?
M and P are congruent.
yeah.
Spoiler alert.
So it's 45?
So what do we know about the diagonals of a kite? They are perpendicular. So we're gonna do Pythagorean.
Oh my god, is that a hypotenuse line?
Is that a hypotenuse?
I'm being serious.
Wait, are MR and RP congruent?
Yeah.
I said for I hate you both.
Wait, this is the
You guys bring the fun out of it.
Literally.
I also.
You guys are too competitive.
Vocabulary.